Welcome to Brain Vision.
In this problem, we are given two balls with different masses and given velocities that are in motion, and they collide with each other as in the figure. They then move off with final velocities VA and VB, which we wish to calculate. We are also given the coefficient of restitution for the system. The first thing we will do here is apply the conservation of momentum, the conservation of linear momentum. And the velocity of balls A and B before and after the impact can be seen in the diagram. So applying the conservation of momentum and taking the right direction as positive, we have that the momentum of ball A, MA, VA initially, so that's subscript 1, plus the initial momentum of ball B, MB, VB1 must equal to the momentum after the collision, which is MA, VA2 plus MB, VB2. This is after the collision. So the mass of ball A we know is 3 kg, and its velocity is 8 meters per second to the right. The momentum for ball 2 is its mass, or ball B rather, mass 2 kg times its velocity, which is 4 meters per second, but it's to the left, so that's minus 4. And this is equal to the final velocity of ball A times its mass, which is 3 VA2. Or in this case, according to our diagram, we just labeled it VA. So 3 VA plus 2 VB. So simplifying, we get that 3 times VA plus 2 times VB is equal to 16. And we'll call this equation 1. So we have a single equation with the two unknown final velocities. But we also have the coefficient of restitution that we can work with. So essentially we need to set up another system of equations in order to solve for these final velocities. So the coefficient of restitution will again take the right direction to be positive. We know that E is equal to the final velocity of B minus the final velocity of A divided by the initial velocity of A minus the initial velocity of B. And so this coefficient of restitution, which is given to be 0.7, is equal to VB minus VA over 8 minus 4. And so if we rearrange this equation, we get that VA, or VB minus VA rather, VB minus VA is equal to 8.4. So yet we have another equation with the same two unknowns. So now if we solve equation 1 and 2 simultaneously, we can find these two unknowns. We have two equations with two unknowns. So solving equations 1 and 2, we get that the velocity of ball B, VB, after the collision is 8.24 meters per second. And that's positive, so that's to the right. VA is equal to minus 0.16 meters per second, and that's 0.16 meters per second to the left.